Hello and welcome to another video by Meston Educational Services. In this video, we are going to teach you how to create the Riemann Sum rectangles on the TI Nspire to estimate the area bound by a curve in the x-axis. So we'll look at the left edge, the right edge and the middle of the rectangle to estimate this area. So before we learn how to create this on a CAS, I quickly want to demonstrate what this is all about. So what you see on your screen is a function, and that is the square root function root x, and I am trying to estimate the area bound by that function and the x-axis between the points 2 and 8 on the x-axis. So we are estimating the area by putting rectangles over there. At the moment you will see I've got 3 rectangles and each of them has a width of 2 units, and the left corner of the rectangle is touching the curve. So we'll refer to this as the left edge Riemann sum method. Now I can also go and change this, and I can have the right corner actually touching the curve, and that would be referred to as the right edge Riemann sum. So I'll demonstrate that. So now if you look at the screen, I've got the right edge of the rectangles touching the curve, and in this case if I was to determine the area of the rectangles is slightly more than actually the area bound by the curve and the x-axis. So we add up the area of the individual rectangles, but you'll see there's an excess area above the curve. So this would be an overestimate, but this will not always be the case. It will actually depend on the actual shape of the curve that we are working with this. In this case, we are working with a square root function. So let's look at if I put the middle of the rectangles touching the curve. So this is actually a closure area determination because some bits of the rectangle are being cut off and there are some extra bits of rectangle that are being added. So on the average, probably this will be very close to the actual area. So this is quite a good estimation. Now I could get more accuracy with this if I increase the number of rectangles. So instead of 3, if I double the rectangles to 6, that would mean the width of each rectangle is 1 unit. There'll be more accuracy. And I could actually go and increase the number of rectangles to 12 or whatever, depending on what interval I am working with. So this is going to be a fairly good approximation. And this is actually the base for integral calculus. So you will look at this formula. When I write the integral calculus formula, it's function times dx. Now dx actually is the width of the rectangle, and this rectangle width can approach 0. Of course we can't make it 0, then the areas for each rectangle would be 0, but we make it approach 0, and that is why we put fx times dx when we actually find the antiderivative. So you can see in this case I've calculated the approximate area, which is 12.478, and the actual area using the integral is 13.199. And this is the left edge method I've used. So it is an underestimation by 5.46%. So negative means it's an underestimation. And likewise, if I change it to the right edge, you will see it's actually an overestimate by 5.25%. And if I use the middle, you'll see it's very close. It's an overestimate by 0.06%. So I've got over here 6 rectangles. I can go and actually increase the rectangles, and I'll just go and do that. Okay, so at the moment I've got 6 rectangles there. So and when I move my cursor before I go up there, it's actually giving the function value. So in the interval 7 to 8, the function value is 2.82. So all I need to do is to take the width and multiply it by the function value. So here I've increased the number of rectangles. Now you've got 12, and then I could actually go and double that, make it 24. And let's use the left edge. So that's the left edge with 12 rectangles, and then I could do the right edge with 12 rectangles, and I could do the middle with 12. Now I've increased the number of rectangles to 24, and I'm still using the left edge over there. So this is obviously going to be a much closer area. So once again, to repeat, this is basically the basis of integral calculus. We first learn with approximation method, and of course then we use the integral to determine the exact area. So now in the next part, I'm going to demonstrate how you can actually create this on the TI Nspire CAS. Alright, so now we are going to learn how to create the Riemann triangle. So essentially what I need is 3 pages or applications. So the first page that you're seeing is called data and statistics page. This one here is a notes page, and actually I've got 2 notes page on one, and I'll show you how I can do that. And the third one is a list and spreadsheet page. So essentially it's 3 pages or 3 applications that I'm going to work with. So and that's of course the formula. I'll show you how we go and put the formula and everything. So let's show you how to add the notes page. First I'm going to add a notes page. So I'll just change my view from computer view to calculator view, so you exactly know which buttons to click and what to do. So let's go and change my view. So here I have changed my view. So if I go into control and dock, it will let me add a application. So here it's asking me what application I want to add. I'm going to add a notes page, and once I've added the notes page, if I click the document key again and I go to page layout, which is option 5, and I select option 2, which is select layout, I'm going to use the second layout. So to I can add 2 applications. So if I click there, notes page, now I actually have 2 notes page there, and I can actually work with either of those 2 pages. So I've added 2 for a reason which you'll realize. Now the first thing I want to remind you is a notes page is where you can type in text, you can do calculations and so on. But if you want to do any calculation or put a maths formula or store a value, then it has to be a maths box. So control M is going to put a maths box. That's what I've just done. I've put letter B over there, and I'm going to assign B a value. So B is like defining or storing, or assign rather, I mean, it's like defining or storing a value. So if I go and put 5 over there, that means next time I type B, the value for B would be 5. And I can obviously go and change that value to any other number. The next thing I want to show you that I'll be doing on the notes page is adding a slider. So here I am going to add a slider. So if I go into menu and insert, and I've got option 5, this slider. So I'm going to give slider the name SLI, and this slider that I'm going to create can take values from 0 to 2. So minimum value is 0 and the maximum value is 2. I want to change that to 2, and I want to go in steps of 1. So my slider will first take the value 0, then 1, and then 2. So I just want 3 values in this particular case. I'm going to minimize it and add the slider. So you can see by default it has gone to 1, but if I go right, it goes to 2, otherwise 0. So I'm going to use the slider on my notes page when I actually show you how to create that. Okay, so let's go back, and I'm going to change my view to computer view because it's more readable. All right, so let's explain you what I've done over here. The first thing you see over there, I've gone and added a variable a. Now a is actually the width of the rectangle. At the moment the width of the rectangle is 2 units, and I can keep changing that. L is the lower bound where I'm finding the area, and U is the upper bound where I'm finding the area. Now all these values can be changed. The next thing where I've just clicked is I'm generating a sequence, and I'm storing that as INTE, so that's interval. So X is the variable, L is the lower bound, U is the upper bound. So I've done U minus the rectangle width time A. So at this stage it's going to give me value that's 2, 4 and 6, because my interval is from 2 to 8. And then if I right down at the bottom is where I'll be storing the function. I've stored the function as root x, but my function is root x, but you could have any function over there. All right, so let's go back. I'll explain each of these again. I'll explain the purpose of the slider. Now I want the rectangles to shift from left to right or to the middle. So the slider is actually doing that for me. So when the value for LRM, which is left, right, middle, I've just called it LRM, the slider. When it is 0, it's the left. When it is 1, it is the right edge of the rectangle that will be touching the curve. And when it is 2, it will be the middle of the top of the rectangle that will be touching the curve. So the logic I've used is when LRM is 0, the shift, I'm storing that as shift SH. So let the value be 0. Otherwise, when LRM is 1, then we are going to say it should be the width of the rectangle divided by LRM. So by that value it is going to shift. So if I have 2 divided by 2, it is going to shift by 1 unit to the right. And if I change the value of A to 1, then it is going to shift by half a unit to the right. And likewise, if I want it to shift to the middle, I'll need to move the slider to 2, and then it will recalculate. So it will take the value of A and then divide it by the value of the slider LRM, and it's going to store this as the shift. So that's the shift factor. So the shift factor would be 0 or A divided by whatever the value is for LRM. Okay, I think so. Now here I've changed the value of A to M. So if I go back to the integral, it will have 2, 3, 4, 5, 6, and 7. So obviously it will stop 1 unit before 8, which is going to be 7, because SH is 0. But if I changed SH to 1, then it will actually start from it won't change over here. It will change on the list and spreadsheet. So it should start from 3 and end at 8. So it's the slider that will be controlling the shift for me. Okay, so once I have done all this, I will actually just go and add 2 fields or 2 columns in my list and spreadsheet page. One would be called INTE, and it's going to pick up the values from here, which are already stored. Okay, I'll just explain quickly what is on the right side of the notes page. So let's go and understand the right side now. So that's the approximate area. So what it is doing is it's taking the width of the rectangle and it is multiplying it by the sum of the function values, and it is picking up this information from the list and spreadsheet page, and it is storing it as EA, which is estimated area, 13.892 in this case. The actual area is determined by the integral. Now what you will notice over there, I have of course stored that, but I'm going to actually hide these values. I don't want too much information displaying, so I'm going to hide the input. I only want to show the result of the area. So now if I click out, you will see it shows approximate area is this, and I can do the same with the actual area. And right at the bottom over there, I've actually got whether it's an overestimate or an underestimate. So in this case, 5.25 is telling me it's an overestimate. If it's a negative value, it would be an underestimate. If you want, you can hide certain other things as well, but I don't feel there's a need to hide. I've actually hidden the INTE value, so that's just the formula that's being displayed. It's not displaying the actual values. Okay, so that's really the key page for us. All the controls are over there. So now I've gone to the list and spreadsheet page. I've got the first column is INTE, and if I click that, you'll see it goes bold because it's picking up the values from the notes page. And if I type in over there, you'll see it goes bold, but of course it will not allow me to enter values there because values are already there. The second column is actually called function value, and it is picking up the function and it's putting in the X value in there as the INTE value plus shift. Now it's a variable reference and not a column reference. So when we actually do that, it will ask you whether you want it as a variable reference or column reference. So it should be a variable reference, because at the moment I've got 5 rows, but the moment I go and change the value of A, it will double the number of rows or probably triple them depending on what the value of A is. So that's just the function value at the interval plus whatever the shift is. So you can see there I've just changed okay, I want to create a summary plot, so that's what I've done. On the X list it should be in interval, and then on the Y summary list it should be the X value. And I've just got a nice looking histogram there, but the curve is missing. So what I may need to do is go and actually add the function there. So menu, and if I go into analyze, you will see there is an option plot function. So my function is already stored as F. So if I click F, I can see my function, but obviously now I need to go and adjust the bin settings and the zoom. So the first thing is I'll change the bin settings, and I need to adjust it to whatever I have for the value of A. Now keep in mind the bin settings will always be the value of A. Okay, I'll just zoom out and you can now see Yeah, I'm changing the bin setting again so that I can see everything. And the bin setting should always be set to the value of a whatever it is. So if I click OK now, yep, and you can see it's the right edge of the rectangles that is touching the curve, and that would mean LM or LRM for me is 1. Now if I change it to 0, if I go back, you will see it will be the left edge of the rectangles that are touching. If I change it to 2, it should be the middle. So now it's the middle. So at the moment I've got 6 rectangles. If I go and change the value of A that I'm doing now, so at the moment it was 1. Let's go and change it to 1/4. And what will happen is it will go and add a lot more rectangles, and going to be 4 times. So I need to go and change the bin settings to 1/4 this time. So bin setting is the value of A. So I'll go and change it to 1/4. Yeah, and now you can see I've got many more rectangles, and it's the right edge that is touching probably. Yeah, so it will depend where I am. So let's go and see what it is. If I change, so it's 2, so it's the middle. If I change it to 1, it's going to be the right edge. So there you can see it's the right edge. If I go back and I change it to 0, it's going to be the left edge. So that's how you actually create a Riemann the sum rectangles, and you can have the left, the right, or the middle. And in this case I've just got the area. It's an underestimate by negative 1.34%. So I don't have to say underestimate with negative. This one here is an overestimate by 0.01. So it's pretty accurate. So this really is once again the basis of integral calculus, and this is how you can actually create the Riemann rectangles on your CAD. Thank you for watching this video.